If a joist manufacturer was asked, "How good are your products?" the answer would almost certainly be, "Only as good as their installation." The joist manufacturer can design and build joist products with remarkable intrinsic strength, but whether or not these products can deliver this strength is totally dependent on how well they're handled and installed. The purpose of this video is to present a clear and concise guide for the safe installation of open web steel joists and joist girders. It's not possible to include every conceivable application or condition in this brief video. However, you should come away with a basic understanding of joists and joist girders and a general knowledge of safe practices for handling, storing, and erecting these products. One of the most important aspects of safe erection of joist products is proper bridging. Bridging is a component of the steel joist system that braces the joists against lateral displacement during erection and placing of construction loads. Lateral displacement means the construction load causes the joist to distort and roll over. This could result in both the ironworkers and joists falling. Much attention will be given to this critical procedure. This video does not address all hazards that may be present in a construction environment. Pre-job planning and development of site-specific plans that identify hazards are very important. The implementation of systems and procedures to eliminate hazards completes this process. Throughout this video, you will see several different types of systems used to protect employees. Regardless of the types of systems you elect to use, they should be designed by a qualified person, and employees should be trained in the proper use of the system. There are two broad categories of open web products. Primary members are joist girders. Secondary members are called joists, which are known by various names including long spans, bar joists, or open web joists. Secondary members, which are either horizontal or sloped, are used for direct support of floor and roof decks and include the Steel Joist Institute designations of K Series and the LH-DLH series. Primary members or joist girders are used to support the secondary members and are supported by columns or other vertical structural elements. A more detailed description of the various products may be found in the standard specifications and load tables published by the Steel Joist Institute. Let's take a closer look at the design of joists and joist girders. Joists are used for the direct support of floors or roofs between walls, beams, and joist girders. All joists consist of the following basic elements: a top chord, a bottom chord, and the interior pieces, which are called web members. The webs are connected to the top and bottom chords. Joists are supported at their ends. This is called the bearing point. An underslung condition is when the bearing point is at the top chord. A square end condition is when the bearing point is at the bottom chord. The top and bottom chords may be parallel, or the top chord may be pitched or sloped. The pitch comes in two forms. The top chord may be pitched one way, or the top chord may be pitched two ways. Combining these elements produces 6 types of joists: parallel chords, underslung; parallel chords, square ends; top chord pitched one way, underslung; top chord pitched one way, square ends; top chord pitched two ways, underslung; top chord pitched two ways, square ends. Joist girders are made from similar elements, but are used for the direct support of joists. They may be supported by walls, beams, or columns. Shortly after the structural fabricator, joist supplier, and erector are selected, a meeting should be held to determine the size of each sequence, shipping schedule, and other related topics. This meeting may include an owner's representative, the contractor, fabricator, and erector. Once the area where erection will start is determined, several factors must be considered. They include the capacity and reach of the cranes, their access and movement, as well as a clean laydown area. Plus, the owner's need of specific areas to be completed early, availability of material, and foundation schedule are also important. Other crafts, such as masonry, concrete, and trades with underground piping, may need to be included in the meeting. Proper access roads for the delivery trucks and erection equipment should be agreed upon. The AISC Code of Standard Practice speaks very clearly in regard to proper access. Other items, such as number of loads per day, suggested delivery times, splicing of extra-length joists, bundling, tagging, possible panelization, number of crane days for each sequence, drawing approval should be addressed. The erector should determine how much erection time will be required for each sequence and schedule deliveries to prevent downtime for the crane. The handling of joist products begins in the joist plant immediately after the joists have been fabricated. They are painted and banded into bundles and moved to a covered location where they are allowed to air dry. The standard shop paint is a primer coat intended to be a temporary coating. When a delivery date has been set, the joist products are loaded onto flatbed trailers. They are loaded upside down to obtain the lowest possible center of gravity. This produces the most stable shipping load. The bundles are then chained or strapped to the flatbed trailer. Prior to arrival of the delivery trucks, the erector should determine where the joist products will be unloaded. Proper timber should be available. Make sure the joists do not come in contact with the ground. It's helpful for the supplier to fax copies of the shipping tickets at least a day before delivery. This will help the erector decide where to unload each shipment. Trucks should be scheduled to arrive at mutually agreed upon intervals so as to minimize waiting time for the drivers. When the truck arrives, the chains or straps are removed, and the erector or other site personnel prepare to unload the bundles of joists. At this time, it is critical that someone checks the shipment for damage. It's also important to check to determine if the material matches the shipping ticket. Note any damaged or apparent missing material on the shipping ticket. The joist supplier should be immediately notified through the erector's customer if damaged or missing material is found.
Dennis, we have one damaged joist.
Be careful when releasing the chains or straps, which are securing the load. Bundles may have shifted in transit and might be in danger of falling off the truck. Another problem from transit happens if a bundle is stressed and breaks its strapping. This is called denesting and can create a dangerous situation. Once a bundle breaks its straps and spreads out, it puts stress on adjacent bundles. This makes the entire load very unstable. When the tie-down chains or straps are released, an unsuspecting worker could be seriously injured or killed by a sudden shift of the joists. How do you prevent this from happening? First, as you're looking at the load for physical damage, check to see if there are any broken straps. However, be careful. You can't always tell. Just like concealed damage, there could be denested joists you can't see. So if you suspect there's a problem, you might hook the crane or forklift to the top bundles before releasing the tie-down chains or straps. Unload the top layer first. Remove the outer bundles and work inward until the entire layer has been removed. It may be necessary to secure lower layers to prevent displacement. Another important point. Keep your hands out of pinch points when handling bundles. The joist may shift without warning and cut or sever fingers. When unloading joists with a crane, 2 chokers in a basket hitch and 2-way spreaders should be used. The chokers are run through the inside equally spaced from each end. The attachments should be made to the chords of the joists at or near a bottom chord panel point. Remember, the bottom chord is up because joists are loaded upside down to lower their center of gravity. In this way, damage to the joists is reduced and the possibility of an unbalanced load is greatly diminished. Also, do not rig joists for hoisting in any manner that produces an unbalanced load. The spreader cables provide a 2-point attachment, thereby producing a balanced load. Another important point. The joist bundles should never be lifted by their strapping. This material is not designed to carry the joist's weights. A strap may hold initially, but can break without warning, seriously injuring workers or damaging equipment. Also, do not rig joists for hoisting in any manner that may damage the web members. Damage to the webs could produce twisting and distortion in the joists. Time will be lost during the erection phase repairing bent joists. It is also recommended that sorting hooks not be used to lift joists for erection. When joists or joist girders are unloaded using a forklift, be sure to adjust the spacing of the forks to prevent damage to cord or web members. All the safety and procedural issues covered in the crane section apply equally well to forklifts. Make sure your forklift operators meet OSHA requirements for training and certification. The joist should be stored in a spot that is removed from the job site traffic routes. Remember, joists and accessories should be set on proper timbers so that they are free from contact with the ground. For the first layer, place the timbers under panel points at equal distances from the ends. Turning the tags in the same direction will help identify members and make sorting them a lot easier. When joist bundles are stacked, timbers should be placed approximately at panel points and in line with the previously placed timbers below. Note, however, it is preferable to not stack joists unless space is limited. It is also advisable to limit the height of the stack to assure stability. Joists should be stored in the same position in which they are shipped, upside down and in a vertical position. If they are laid over on their sides, the cords are more apt to be damaged, and sweep and distortion of the joists are likely to result. If straps have been broken or stretched and the joists have become denested, the joists should be resecured to prevent damage. When it's time to place joist products on the structure, there are several initial safety factors to remember. Proper handling and rigging techniques must be used, the same ones we learned in unloading. This includes never lifting joist bundles by their strapping. They break. Do not lift by the joist webs. It can damage them and produce twisting and distortion in the joists. Always keep your hands and fingers safe. Avoid pinch points. Remember, joist products are shipped and stored upside down. Therefore, they must be turned right side up to erect. Then they have to be separated. When a joist girder is being removed from a bundle, care should be taken to ensure that the remaining joist girders in the bundle will be secure and stable. Hook the cable at the midpoint of the bottom of the joist girder to remove it from the bundle. To turn a joist girder over, lift by the bottom cord, lay it on the timbers, and unhook. Then rehook the top cord for hoisting to the connectors. Make sure you check the mark number on the tag before sending it to the connectors. Check the erection drawings if you're not sure. Prior to erecting joist girders, it's helpful to plumb columns. Check each column with a bazooka bob, 4-foot level, or plumb bob in each direction. Adjust the leveling nuts as needed. Be sure to leave one leveling nut in its original position in order to maintain proper elevation. A little extra time spent here will make it much easier to erect joist girders and maintain proper bay spacing. Typically, joist girders are connected to columns. The first joist girder is usually erected with connectors working from man lifts or ladders. Each company must determine their preferred method of fall protection. Some companies rely heavily on man lifts. Others prefer to use lanyards and lifelines. The connectors should check which way the tag goes before leaving the ground to erect the joist girders. The riggers should use proper technique. 2 chokers in a basket hitch with 2-way spreader cables works best. As each joist girder is lowered into place, one connector makes the first end. Then the other connector makes the other end. Sometimes the ground person needs to loosen the anchor bolts on one side of the column. This allows alignment of the column in joist girder holes. Then the erection bolts are installed. Column adjustment is often necessary if they are not plumbed as described earlier. Once the bolts are installed, the connector tells the ground person to retighten the anchor bolts. Once the girder is checked for stability, he tells the other connector to release the hoisting lines. On structures that do not have beams framing between columns in both directions, the first joist to be erected is the tie or strut joist. This joist frames between the support beams or joist girders at the column lines and is always bolted. Typically, the joists will have slotted holes. Therefore, the base spacing must be checked. This can be accomplished by taping in the air or by marking the tie joist on the ground. It's usually safer and more efficient to measure on the ground. In bays where the joist erection drawings do not show a center row of X-bolted erection bridging, it's permissible to land the joists in bundles. Before this can be done, joists must be sorted out on the ground and proper numbers placed in bundles for erection. Be careful when cutting the straps. Keep hands and feet clear. Joists may move and sometimes fall over when the straps are cut. Typically, 4 to 6 joists will be hoisted in a bundle, depending on the actual number required in bay. Be sure all the tags are turned in the same direction. Also, check that the ends are even and all the joists are in proper sequence to be spread out on the building. Finally, check the joist erection drawings for proper joist spacing and length of bearing. Now, the spacing of joists in bays must be marked on supporting beams or joist girders. This is typically done after members are erected, but with proper planning can be done on the ground. On joist girders, the final marked locations must occur where the web members connect to the top cord. Ironworkers must take extra time to verify this. The ironworker should inform his supervisor if this condition is not met. When erecting joists in bundles, connectors should land the bundle in the approximate center of the bay. Check for proper bearing at each end before releasing the cables. When releasing the cables, be sure to hold them until they clear the bundle or swing the crane away from the bundle so that they don't hang up. After the cables are released, make sure all the joist ends are sitting flat on their supports. If necessary, use a spud wrench to shift the joists into the flat position. Be careful to keep your fingers clear and don't lose your joist bearing. If the joists are not to be spread and attached promptly, the bundle should be resecured to prevent unintentional displacement or falling. Now you're ready to spread the joists. Ironworkers on each end should work closely together while sliding individual joists into their final marked location. Great care should be taken to maintain equal bearing at the ends. A final check should be made to verify that the joists are resting where the web members connect to the top cord. When the joists are in the correct location, you need to attach both sides of one end as soon as possible. Attachment may be achieved by either bolting or welding in accordance with SJI specifications. Some erectors may choose to string, Christmas tree, or employ multiple lift rigging procedures of several individually rigged joists. If you elect to use this practice, a trained qualified person should do the rigging and sound rigging practices should always be followed. This method should not be used to hoist multiple bundles of joists. Remember that bridging is a critical component of the steel joist system. Its purpose is to brace the joists against lateral displacement during erection and placing of construction loads. In order for bridging to function properly, it must be anchored. This can be accomplished by securing the bridging to a fixed object, such as a wall, steel beam, or other stable portion of the structure. This anchoring point for bridging is referred to as a terminus point. Depending on the type and length of the specified joists, 2 criteria must be met before the hoisting cables may be released or any erectors are allowed out on the joists. Required erection bridging must be installed and both sides of at least one end must be attached to the supporting structure. The erection bridging may be installed from a man lift. For the specific requirements of the joists being erected, ask your supervisor and consult the joist erection drawings. Sometimes center X-type bridging is bolted to the joists on the ground. Then, as the crane stabilizes the joist, an ironworker attaches the loose end of the bridging to the existing joist up on the structure. This is usually done by standing on a walkboard bearing on the bottom cords of the previously erected and bridged joists. In certain design applications, the joists are designed to bear on the bottom chord. Because these joists have a higher center of gravity, they exhibit an additional instability. In effect, they are top-heavy. Therefore, they must be braced with an additional row of X-type bridging at or near the bearing as they are being erected. Remember, before going out on any joist, be sure that at least one end is attached on both sides and required erection bridging has been installed and anchored. Never forget, unsecured joists can and will roll over. Finally, attach the other end of the joist by welding or bolting each side. Now, this is very important. If joists don't fit or conflict with other materials, don't cut or alter them. If field modification is necessary, permission and instructions from the joist manufacturer and the engineer of record must be obtained in writing. A growing number of erectors are panelizing joists on the ground. This is done in full or part bays, depending on the total weight of the lift and crane capacity. This is definitely a safer method of erection, and with proper planning is more productive. Here are the basic steps for panelization. Create a work platform on the ground to simulate actual supporting members. This can be done with dummy beams or joist girders spaced to match the actual bay. Be sure these members are adequately braced to prevent overturning. It's critical that the support frame must be square. Mark joist spacing. If several typical spaced bays are to be assembled, clamp a plate or angle to the support frame to mark each location. Place joists on the supports, either individually or in a bundle depending on the size of the joists. Check the spacing and bearing of each joist. You may want to tack weld or clamp a piece of angle to the support frame as a bearing control. Install and weld all required bridging. Prior to tightening the bridging bolts, spacing and alignment should be checked. Be sure there is no sweep in the joists. You may have to use a come-along or other method to straighten joists. Be sure to locate the bridging for proper lap at splice points of an adjoining panel. If touch-up painting is required, it's easier now than after erection. In certain cases, you can install roof opening frames prior to erection. Careful measurements must be made to assure proper location of the frame. A variety of lifting frames or beams are used. The lifting device should be designed to lift each joist, be properly balanced, lightweight, and easily released with minimum fall exposure to connectors. It's important not to warp the joist panel during hoisting. When landing the joist panel, check for proper bearing. If the panel includes a tie joist, all of its bolts must be installed prior to releasing the crane. There are many methods of panelization. Some erectors prefer to assemble full bays, including the tie joist. Others install the tie joist prior to erecting the filler panel. Still others panelize in 20-foot widths to accommodate standard bridging lengths. Most joist suppliers will work with erectors for special length bridging as long as it can be cut from standard stock lengths. Clear communication between the erector and joist supplier can result in less field cutting and splicing. An additional benefit comes from less material waste and labor time. Current OSHA regulations allow for joists to be erected in panels without supporting members being punched for bolts. An exception is made at tie joists, which must be punched. If you're not utilizing panelization, here is another important safety requirement. On structures that do not have beams framing between columns in both directions, the joists or joist girders must be field bolted at or near the columns to provide lateral stability. As we've described before, bridging is a component of the steel joist system that braces the joists against lateral displacement during erection and placing of construction loads. The number of rows of bridging is dependent on the length of the joist, as well as the size of the top and bottom chords. In a lighter, shorter joist, fewer rows of bridging are required to stabilize the top and the bottom chord. Without bridging, joists can easily turn over or lose their bearing. Once the construction load is applied to the joists, the chord members tend to displace laterally. This could result in a serious accident. Even if the joists are attached to the supporting members, they can still fail. Proper bridging solves this problem. The most common bridging material is angle. Typical sizes range from 1 inch by 1 inch up to 2.5 inch by 2.5 inch. In special applications, even larger sizes may be used. It's important to understand that the steel joist system will not function to support the erection loads without this component being in place. Before bridging can be installed, it must be landed up on the structure. OSHA requires that a bundle of bridging not exceed a total of 1,000 pounds. In addition, the bundle should be placed on a minimum of 3 joists and within 1 foot of a secured end. In general, bridging is either classified as horizontal or diagonal. Horizontal bridging consists of 2 continuous horizontal steel members. One is attached to the top chord and the other attached to the bottom chord of each joist. Each connection to the joist is made by welding or bolting. Diagonal bridging consists of cross-bracing connected to the top and bottom chords of adjacent joists. It's also connected where the diagonal pieces cross. Connections to the chords of steel joists are made by welding or bolting. The Steel Joist Institute has load tables in their standard catalog that have been developed through extensive testing and study. They recommend that some joists as short as 23 feet should have the bridging installed prior to releasing the crane hoisting lines. As an erector, it's important to understand that the steel joist system will not function to support the erection loads without this component being in place. Therefore, the erection bridging must be installed prior to any load being exerted on the joists. This is the recommendation by the SJI tables and field use erection drawings for all joists. In addition, the Steel Joist Institute has guidelines for the type, spacing, and length of joist as to the number of rows of required bridging. For example, when the joist is over 60 feet in length, all rows of bridging must be bolted diagonal bridging. And at least 2 rows of bridging must be installed as erection bridging prior to releasing the hoisting lines. When the length of the joist is over 100 feet, then all the rows of bolted diagonal bridging must be installed prior to releasing the hoisting lines of the crane. Before any construction load is applied, all the joists must be safely and completely erected in an area or bay. This means all the bridging is in place and anchored. It also means both ends of the joists are attached. Typically, a load consists of metal decking. Current OSHA regulations require that bundles of metal decking be limited to 4,000 pounds or less. The metal deck bundles must be placed within 1 foot of either end of the joist, and the bundle must span a minimum of 3 joists. Do not stack bundles. Now, in some applications, it's not practical to bridge the entire bay and/or project prior to spotting or landing metal deck on the joist. When this is the case, the steel erector must determine, using a qualified person, that the structure is capable of supporting a load of decking. This is done through a site-specific erection plan. At the very least, the joists that are supporting the bundle of decking should have the load distributed over a minimum of 3 joists. In addition, both ends of the joist must be attached in accordance with the field use drawings, as well as at least 1 row of bridging installed and anchored. Joists must be fully installed and bridged prior to placing construction loads other than deck bundles. The Steel Joist Institute and the Steel Erectors Association of America hope you enjoyed and learned from this program. Our goal was to present a clear and concise guide for the safe installation of joist products. Remember, we did not attempt to cover every possible erection application. In addition, we didn't address all potential safety hazards found in today's construction environment. However, you should have gained a basic understanding of joists and joist girders and a general knowledge of safe practices for handling, storing, and erecting these products. For additional resources, please contact the following organizations. For additional videotape copies of this program, please contact SJI or SEAA.